Okay, so we're in Algebra 1, second semester is Chapter 6 to start. Chapter 6 is on linear inequalities. So a lot of what you just did for equations in Chapter 5, we're now going to do for inequalities, okay? So first, an inequality is just a way to compare two values, okay? So we're going to use a greater than, a less than, greater than or equal to, and less than or equal to. Okay? It is always open to the bigger number. It's always pointing at the smaller one. These two imply that the left and the right could also be equal, or one could be bigger than the other. Okay, so an example would be like x is greater than 2. So this is talking about any number that's bigger than 2, not including 2. If we said x was greater than or equal to 2, right, this examples would be 2.1, 2.05, 3, 10. Okay, when we include it, you're going to, when it says it's greater than or equal to, it's all of those as well as 2 itself, because 2 can be equal to 2. Okay? So we can graph linear inequalities. We graph them similarly to graphing a linear equation in one variable. Okay, so it's going to be all points or all values, okay, on your number line that represent the solutions. So if we say all real numbers less than 3, we're looking at all real numbers is going to be represented by x, less than, so x is a smaller, so 3, so x is less than 3, okay, and if we want to graph this, we draw our number line, and then remember when we were graphing them, I said you need the number itself, one number less than, and one number greater than. Okay? Numbers less than 3 are to the left. So 2 is less than 3. So we're going this way, right? And then 3 is not included. So we need an open circle at 3. And then anything shaded to the right, or to the left, sorry. Okay? All real numbers greater than -3. Again, x is all real numbers greater than -3 is written that way. And then if we graph that, -3 is in the middle, -4 is to the left, -2 is to the right, because we're getting bigger going this way. We're not including -3, so we're going to have an open circle at -3. But then we want anything bigger than that. So anything bigger than that is to the right. So we would shade this way. For greater than, we're going to say all real numbers greater than, or let's say less than or equal to 2. So all real numbers less than or equal to 2. So this time we want to include 2. So to include it, we need to fill that circle in to say we want 2 as part of our solution. And then numbers smaller than 2 would be to the left. And all real numbers greater than or equal to -1. So x is greater than or equal to, put that line under it, -1. When it comes to graphing, -1 is in the middle, -2 to the left, 0 to the right. Again, I want to include -1, so I need to close that circle in, and then values bigger than 1 are to the right, or bigger than -1 are to the right. So this way. Okay? So graphing them, greater than or when you're doing the equal to, your circle is closed in. When you're not equal to, the circle is open. And then you shade left or right depending on where the values are that make it a true statement. Okay? In this is solving one-step linear inequalities. So in the past, we've learned how to solve x plus 4 equals 5. Okay? So we want to isolate x, figure out what it has to equal to, so we're using the inverse operations. So we're adding 4. So to solve this, we subtracted 4 from both sides, and we said that x had to equal 1. Okay? Solving a linear inequality is done the same way. So the goal here is to isolate the variable on one side. Okay, using your transformations. So the transformations we can use with inequalities are slightly different. Okay, for the most part, they're the same. They change a little bit with multiplication and division. So you can add the same number to both sides. Okay, so we have x minus 4 is greater than 5. I want to get x by itself. I'm going to add 4 to both sides because that's the inverse operation. And I get that x is greater than 9. I've solved the inequality. Okay, I added. I can subtract the same number from both sides. Again, that's the key, is it has to be from both sides. So I have x plus 5 is less than or equal to 10. I want to get x by itself, so I'm adding 5, so the opposite is to subtract 5. So I get x is less than or equal to 5. Okay? Again, adding and subtracting the exact same way. Multiplication and division are a little bit different. Okay? You can multiply and divide each side by the same positive number. So I want to solve, I have 1/3 x is less than 3. To get x by itself, you multiply by 3. So I get x is less than 9. We have 2x is greater than 6. The operation is multiplication, so to undo that, I'm going to divide both sides by 2. And I get x is greater than 3. So I multiply and divided both sides by the same positive number, and I was fine. What changes is when you multiply and divide both sides by a negative number, you must switch your inequality. Okay? So if I want to solve negative x is greater than -3, to get x by itself, you're dividing by -1. So you have to switch the sign. So x is going to be less than +3. We have -3x is less than 15. Multiplying by -3, so we're going to undo that by dividing by -3. This is negative here, so you switch your sign. So x is now greater than negative 5. Okay, so the steps are the same, except when you multiply or divide by a negative, then flip your inequality. So we're going to solve x plus 8 greater than or equal to 1 and graph them. 3 is less than m minus 5. P over 2 is less than or equal to negative 2. And negative 2.5 y is greater than 3. Okay, so x plus 1 is greater than or equal to 8. To get x by itself, you do the inverse of addition, so you subtract 8. We're allowed to do that. We're just adding and subtracting. So x is greater than or equal to negative 7. Okay, to graph this, you go to your number line. I'm going to put negative 7 in the middle, negative 8 on the left, negative 6 on the right, greater than or equal to, so close circle on the negative 7, and then numbers bigger than negative 7 would be to the right. Three is less than m minus 5. The opposite of minus is to add. We can add the same number to both sides. So 8 is less than m. That's fine. You could rewrite that and put m on the left. So we're going to say then m is greater than 8. Okay? It's open to the same thing on both. So either one of those is accurate. To graph it, 8 goes in the middle, 9 on the right, 7 on the left. It's strictly greater than, so we have an open circle on the 8. Okay, values bigger than 8 are to the right. So we're going to shade over 9 with our arrow there. Okay. P divided by 2 is less than or equal to negative 2. To undo this, we're dividing by 2, so we need to multiply by positive 2. We multiplied by a positive, so we don't worry about our sign. So we get P is less than or equal to, because we're going to keep it. Negative 2 times 2 is negative 4. To graph this, go to your number line. Negative 4 in the middle, negative 5 on the left, negative 3 on the right. Less than or equal to, so we close in that circle on negative 4. Values smaller than that are to the left. So we're shading to the left. And we've got our graph. All right, last one, negative 2.5, it's a decimal right here, times y. So to undo that, you're dividing by negative 2.5. So that's how you get y. You divide it by a negative, so you switch your inequality, so y is less than, and then you get negative 1.2. On the number line, I'm going to put negative 1, negative 2, and 0. Negative 1.2 is just to the left of negative 1. Open circle, and then values smaller than that are to the left. And we've graphed that inequality. Okay, so that is solving and graphing linear inequalities with one step. So 6.1.